In this video, we'll discuss significant figures and calculations. You can use a calculator to help you work problems faster, but you still need to understand how to round those numbers, your final numbers, for significant figures. When you perform a calculation, you want to round to the correct number of significant figures. If the first digit that you need to drop is 4 or less, then you're going to keep the number that preceded it. If the first digit to be dropped is 5 or greater, then you're going to increase the last retained digit by 1. So keep all of your digits as you do your calculation, keep them all in your calculator, and round your final number to the correct number of significant figures. For example, let's say on our calculator we have the number 8.4234. Let's say we need to round this number to 3 significant figures. Then we need to round to the hundredths place in this number. So in the hundredths place, the number we have is a 2. We're going to look to the right of that number, which is a 3, and since 3 is 4 or less, okay, so it's less than 4, we're going to keep the number next to it the same. So our number with 3 significant figures would be 8.42. Okay, and we're just going to drop the 3 and the 4. If, on the other hand, we wanted 2 significant figures, then we're going to look to the right of the second significant figure. So that would mean we had 8 point and then the number in the tens place as our final number. To the right of it we have a 2, and so again we'll keep the 4 the same. So we have 8.4 as our answer, and we're going to drop the other digits. Let's say that the number in our calculator is 14.780, and we want to convert that to 3 significant figures. Then we look to the right of the third significant digit, so that would be 147. We look to the right of the 7, and we have an 8. Since 8 is 5 or greater, so it's greater than 5, we're going to increase the value of the last significant digit, the 7. We're going to round it up to 8, and that would make our final number 14.8 with 3 significant figures. On the other hand, if we wanted to have 2 significant figures from 14.780, we would need to round to the ones place. So we look to the right of the number in the ones place. The number in the ones place is a 4. We look to the right of that and we have a 7, which is 5 or greater. It's greater than 5. And so we're going to round that 4 up to a 5. So if we wanted 2 significant figures, our number would be 15. Next, let's consider the number 3256. Okay. If we want to convert that, or if we want to round that to 3 significant figures, we look to the right of the third significant figure. The number that is the third significant figure is 5. That's in the tens place. To the right of the tens place is a 6, which is 5 or greater, meaning that we need to make our number 3,260, okay, where the 0 is insignificant. So technically this is okay, but it is ambiguous. And in order to remove the ambiguity from the number, we need to convert it to scientific notation. So let's start all over with that. 3256. We want to round to 3 significant figures. So we look at the number that's the third significant figure, that's a 5. We look to the right of it, which is a 6. That number is greater than 5, so we're going to round to 3,260, which means that the 0 is not significant. But this number is ambiguous, and so we want to remove the ambiguity. In order to do that, we're going to convert to scientific notation. So we know there's an implied decimal point there. In order to convert to scientific notation, we move it 3 places to the left. That means that our final number would be 3.26 times 10 to the third. So this is the correct number to three significant figures, and the ambiguity has been removed. We're sure that we have three significant figures in that number. On the other hand, if we want to convert 3,256 to two significant figures, we look at the second significant digit, which is a 2. We look to the right of it, and it's a 5. So since it's 5 or greater, we're going to increase the value of that last digit by 1. So our number becomes 3,300. But this is ambiguous. So in order to remove ambiguity, we're going to convert to scientific notation. We move our implied decimal place 3 places to the left, which gives us 3.3 times 10 to the third. Now we have two significant figures, and we've removed the ambiguity in our number. Let's take this number and round it to three significant figures and then two significant figures. We have 3.1457. Let's look at the third significant figure. That's a 4. Looking to the right of it, we have a 5, which is 5 or greater. So that means 3.14 would become 3.15 when rounded to three significant figures. To round it to two significant figures, we have the number 3.1457. If we look at the second significant figure, it's a 1. So if we look to the right of it, it's 4 or less. So we're going to keep our second digit. So that's going to be 3.1. So rounded to two significant figures, the value is 3.1. When performing a calculation with significant figures, if we're multiplying and dividing, we want to keep the final answer with the same number of significant figures as the measurement with the fewest significant figures. So we limit our final answer to the number with the fewest significant figures. So in other words, if we multiply 24.66 times 0.35, our final answer in the calculator would be 8.631. We need to round that to two significant figures because the answer with the smallest number of significant figures is 0.35. So we look at the second number, the second significant figure in our answer on the calculator display, and that's a 6. If we look to the right of it, it has a 3. That number is 4 or less, so we're going to keep our answer the same, and so our final answer will be 8.6 with two significant figures. Now let's do an example with division. Again, when multiplying and dividing, your final answer will have the same number of significant figures as one of the numbers in your calculation, the number in your calculation with the fewest number of significant digits, or the measured number that you have with the fewest number of significant digits. So let's multiply and divide the following number. So here we have 21.5 times 0.30 divided by 1.88. So to put that into the calculator, we'll put 21.5, hit the times button, and then 0.30. Then you could hit equal, or you can just hit divided by, and then 1.88. So the answer in your calculator may be 3.430851063. You need to round that to two significant figures because the part of your calculation, the number with the least number of significant figures, is 0.30. So that has two significant figures. So you need to limit your answer to two significant figures. Therefore, you're going to look at your second significant figure, which is the 4, and you're going to look to the right of it, which is a 3, and that's 4 or less. So you're going to keep your number the same. You're going to keep your second digit the same. So your final answer will be 3.4 centimeters. Sometimes when you're dividing and multiplying a measured number, you may get an answer that has fewer significant digits than required for your final answer. If that's the case, it's because your calculator will leave off the extra zeros. For example, if you divide 6.0 by 2.00 on your calculator, You'll know that you should have two significant figures, but 6 divided by 2 is 3, and 6.0 divided by 2.00 is still 3, so your calculator will just display a 3. Since you need two significant figures, the way that you'll achieve that is to add extra zeros to make up the number of significant figures you need. So you'll put 3.0 as your final answer. Let's perform the next calculation. 5 times 3.408 divided by 2.0. So that's the way we'll put it into the calculator. 5 times 3.408 equals divided by 2 equals, on our calculator we may see 8.52, but we should have two significant figures in our final answer. So we'll need to round 8.52 to two significant figures. The 5 is our second significant figure. If we look to the right of it, we have a 2, which is 4 or less, and therefore we keep the 5 in our final answer, and we'll say 8.5. Adding and subtracting measured numbers has different rules for significant figures. So when adding and subtracting measured numbers, you're going to keep the same number of decimal places as the measurement that has the fewest number of decimal places. This is something that students get confused a lot, so be careful here. For example, with this number, we have 2.012 plus 61.09 plus 3.0. The first number, the top number, has 1, 2, 3 decimal places. The second number has 2 decimal places, and the third number has only 1 decimal place. When adding those numbers together, our calculator display will be 66.102. We know that we need 1 decimal place because the smallest number of decimal places is in the bottom number, which only has 1. And therefore, we'll need to round our final answer to 1 decimal place, meaning our final answer will be 66.1. Let's add these measured numbers. 82.409 plus 22.0. 22.0 has the fewest number of decimal places, which is 1 decimal place. When we add those numbers together, our calculator will display 104.409. We have 1 decimal place, which should be in our final answer, and therefore we'll round our final answer to the 10th place, which will be 104.4.